Great to be back. Second time at MFD. I am still Nick Swiatecki. I'm still that on all the medias. I think I still have all of those titles. But kind of my day job is, being a leader in our product management team. I was thinking, okay, what do we present here? I kind of took the same approach as last time. Present the stuff I would love to have heard if I was, sitting in your chairs today or at home streaming it from wherever you are. So, really quick, this is the agenda for the next 24 minutes. Follow up from last time. You'll hear me refer to the November presentation quite a few times because, we're following up on some of the items we kind of talked about there. And let's just geek out a bit for 24 minutes. Cool. I have a lot of content, so let's just get started. Now, first, just get us warmed up. Sam, I have a question for you. What is the down tilt angle of this AP?
That appears to be 48.5 degrees.
Beautiful. So I wanted to start with just a very basic thing that we've been doing, and I'm actually kind of super proud of this, right? For a lot of time, we install access points at angles. Now with 6 gigahertz, and having integrated directional antennas, this becomes more and more apparent, right? We can't always rely on external antennas, and we put out a 9166D1 that is integrated directional antennas. You're not going to go around and measure the angles of all your installed APs. You might make beautiful designs in your design tools. I'll almost guarantee you that's not what the real world looks like. I see a few people nodding. So this is just a little tip to get us started, but let's just ask the AP. In November, we talked about us putting accelerometers in the access points. Happy to announce that starting 17.15.1, you can go pull this data off the wireless LAN controllers, and we're putting in the Meraki dashboard soon after. For those Norwegian Grafana-loving wireless folks, you know who you are. You can do way better than I can. So crazy. But just wanted to kind of give a shout out that that's going to be available. Super elegant, small, very impactful feature. Anyways, another kind of, before we dive into Wi-Fi, a little PSA and refresher on PoE. Switches are my favorite kind of power injector. But as we kind of move beyond Wi-Fi 6E and into Wi-Fi 7, we are going to see more power-hungry APs, and you'll see these advertised as, needing BT. You'll see switches with BT. But just once and forever, can we all agree to not call them BT switches and BT APs? BT is a protocol. It says nothing about how much power that's available, and I've highlighted here. You can have a BT switch that gives you 30 watts. So please, just can we all agree, don't call it a BT switch. Let's see how many watts each port can deliver. Or we can get more nerdy and we can talk about PoE classes. Anyways, I'll get off my switching soapbox right now, but I'm pretty sure we all need to start kind of retraining our brain. Also, is it 2-pair or 4-pair power? There's a lot of good geekiness to dive into in PoE, but more on that in another session. In November, I presented this slide, the Wi-Fi trifecta of readiness. I still like it. I still think it's awesome. This basically talks about what kind of components do we need for a new Wi-Fi innovation to be adopted, right? We need the specs, the regulatory. Think about this in the lens of 6 gig. You need the clients, you need the hardware and software to be ready, and you need the infrastructure. And when we have all of these, great. Now you can actually, operate a new Wi-Fi standard or a new Wi-Fi kind of spec. Which leads me to AFC. Now, back in November, we did the whole deep dive of architecture, a demo, and Wes was nice enough yesterday to give us kind of a refresher on all of the regulatory requirements. So I'm just going to kind of jump to the good part. We're live. So as of a few days ago, there are 44 APs that have been certified for standard power use in the US. 20 of those are Cisco.
Good Lord.
We've always been at the forefront of this. So the moment this went live, the moment the FCC said, go ahead, we'll issue certifications, we're right at the top of that queue. We didn't make it as the first equipment vendor. We made it as the second, but I'm happy about that. And since mid-April, we've been live. If you have a 9800 controller, 17.12.3, hit on. If you have, for example, 9163E, outdoor AP, you have standard power. Meraki is going live in just a few weeks. So super stoked to, I guess, re-announce that we're live with AFC, and you can start running it now. Now, of course, on clients, another quick update here. There are 2 different client types in 6 gigahertz. Most of you are familiar. I see a few nods. But a quick update. In November, we were at about a 4-to-1 ratio between indoor clients and dual certified clients, right? Dual certified clients being the ones that can both do LPI and standard power. Happy to report we're now kind of closer to a 1 to 1.5 ratio, which is amazing because that means more clients will be able to just, use standard power right away. Also, I think somebody yesterday asked,
That was me.
what about standard client? Do we care? The answer is no, there's 4 of them. So we truly don't really
Unless
care.
you have those 4 clients, of course.
Unless you have those 4. And it looks to be right now more point-to-point-ish specialized stuff, right? So what you really want to look at is these dual certified clients. Now on the software side, as it often is with Wi-Fi, Intel, software support's there. Android, software support is there. Apple, not yet, but they are certified, so just a matter of time. What do we all love? Clients, clients, and clients. Now, back in November, I remember Keith's face, or maybe it was Sam's, when I kind of alluded to...
They're so similar.
Clients aren't telling you what they're capable of. Seems like a huge gap. Like, wait a minute, the clients don't tell me if I can actually operate at standard power. So Sam goes, deploys an outdoor AP, he has the client that supports it, but we don't even know if it's standard power or not. Seemed like a huge gap, right? Now, imagine if you have an integrated access point today, let's say a 9166. You can run it in LPI mode, but you could choose to run it in standard power mode as well. It's your choice. You might want to run in standard power because you get more power on smaller channels. But how do you know if your client supports it? You don't. So we sent our standards people to work. And as of the latest ME version 5 draft, and I'm sure Adrian is listening out there, there's actually the introduction of a new field. There's 2 fields. One means the other field is valid. But we took the time and we sent our status folks to work and said, please let the clients announce what they're capable of. So assuming this all gets voted through, we're going to have elements in a SOC and ReaSOC telling you, hey, I'm capable of LPI, or hey, I'm capable of standard power. There's also indoor SP, and we'll talk a bit about it in a moment. But super exciting. It's one of the problems we identified industry-wide, and we went to work, went to IEEE and said, listen, we need to fix this. And it looks like it's getting fixed. Secondly, on the access points, I call this slide the difference a bit makes. So today, an AP will announce, am I LPI or am I standard power? Little restrictive. That's what the clients use today to determine, can I join this AP? So an Apple client would see an AP with this bit set to 1 and say, nope, I'm not going to join. Little restrictive, doesn't really allow for future use cases where, what if I want standard power indoor? Again, we went to work. In the newest rev of the spec, the value 4, you might have heard about this, if you're really an AFC aficionado, you went to WPC, is getting depreciated. We're moving to 8. Now, I'm not going to talk too much about bits and bytes more, but the beauty of this is that allows backward compatibility for LPI clients. LPI, traditional clients, just see that last bit as a 0 and say, OK, I can join. So again, one of the initiatives to go work with the standards to make sure we can actually deploy 6 gig Wi-Fi in a sane manner. Makes sense? I see a few nods. Some people are like, wait, did he actually just show bits and IEEE's? I see a few people doing thumbs up, but yes. And this is the level we've gone to make sure that 6 gig Wi-Fi becomes a success. Cool. So shifting gears here a little bit. Again, you'll hear me say, we presented this slide back in November, and we did, and this is still true, right? The true paradigm shift is 6 gig Wi-Fi. Is not Wi-Fi 6E or Wi-Fi 7, right? They just use this spectrum. But that also means that we need to start talking about APs in a different way. Here's kind of my suggestion, but I want to call out, right? Wi-Fi 6E explicitly has support for 6 gigahertz. Wi-Fi 7 doesn't say anything about that. It's just an option. So when you see a Wi-Fi 7 AP, the first thing you should be asking yourself, Fernay should be asking anybody, hey, is that a dual band, dual radio AP? Is it a tri-band, tri-radio AP? Can it do all the bands at the same time? So my little appeal here to the audience is let's start talking about APs in a different way. Let's start talking about what bands is it capable of? What bands are it capable of simultaneously, right? Because if you just see a Wi-Fi 7 AP, you don't know any of this. Anyways, getting off my second soapbox here. Okie dokie. Well, couldn't show up, talk about Wi-Fi 6E and 7 without teasing you guys a little bit. I wanted to share some of the discovery we've done being kind of on the bleeding edge of Wi-Fi 7. Some of the stuff that's probably not available to you, but aha moments for me that I thought was worth sharing. So, first of all, I'm actually not going to get you all to say it with me, but when Drew looks up from the slide, nah, just kidding.
You're going. I'm trying to keep up over here. I'm just saying.
MLO is multi-linked to the same AP. Please. You all guys probably know this. If not, now you do. It is not to multiple APs. That's maybe in Wi-Fi 8. I see Jerome's face right down here, so he can talk more about that if he wants to. But MLO is just,
You
single
we're
AP.
going to talk about Wi-Fi 8? Do you have an AP?
Fair point. I did think about bringing the biggest box I could find and saying this is our 16 spatial stream AP. I did see the Twitter threads. Yeah. No. Coming back, MLO, one AP, right? Not multiple APs. So let's talk more about MLO. Back in November, I may have claimed that this is the one to pay attention to. And I'll explain what all of these means in just a second. But turns out this one on the right is also very, very important to pay attention to. So let's start doing that. Forget what's in the middle. In MLO, there are two predominant terms that matter. MLMR, multi-link, multi-radio. So a device that has two radios, and two full radios. And then on the far right, you have eMLSR, enhanced multi-link single radio. Now, why do I suddenly care a lot about eMLSR? Because that's what the Intel chips can do right now. So the first wave of Wi-Fi 7 client devices are all eMLSR when you have them from Intel. So we should probably talk about that. Now, MLMR, again, two radios operating independently, can transmit on their two different bands completely separately. What happens on eMLSR is single radio that looks for the first available TX op. Might be 2.4, it might be 5, it might be 6. And we'll find the fastest one, and it'll switch between them. So technically not sending traffic, at the same time, just switching between the links in whatever sense makes matter. It is a little more complicated. There's signal involved. It's two-way. But these are kind of the main two terms. If you educate yourself on MLMR, eMLSR, you're going to be ready for kind of the first wave of MLO. There are also some terms, STR and STR. STR is the one that matters. Just forget about and STR for now. So I'm going to make a statement here. Enterprise Wi-Fi 7 still very much dev only. This is truly what I imagined when I thought I was going to start labbing with Wi-Fi 7. Right? Just go and install in 320 megahertz. I mean, in reality, it is still very much like this. To get MLO, you have to be not on the release candidate of Windows, not the beta, not the canary, the one that's like, hey, this is very unstable, you can't upgrade it. Then you need dev drivers that are not publicly available, and thanks for the chips that vendors providing them to us. And sometimes you even have to go registry edit, mingle around with new values to actually make the clients behave in a way we would like them to. So all of you who've had fun with client roaming, MLO might be the same way, where for the first many iterations, it's a black box, we don't really know what happens. Okie dokie. But I just kind of wanted to show you something cool here. So what does MLMR actually look like in action? So this is multi-link, multi-radio. And what you see here on the top left is we're pumping, I think, a measly 50 meg throughput. And down here on the spectrum analyzer, you'll see, yes, we're seeing traffic in 5 gig. Again, this is a device that is capable of 5 and 6 at the same time. There is no 6 right now. Now, what we're going to do is we're going to bump up the traffic. I think we've turned up 5 gig, just a lot of traffic. Suddenly, you'll see the 6 gig band kick in. So client behavior is going to be the key to when and how MLO is used. We don't get to control it. And now you can see the two spikes, and we're transmitting at both. This is only when we start pumping traffic. You don't get to control this. Just want to show you this because honestly, it's kind of cool. But it also just goes to show we don't have all the control as the infrastructure. It's going to be a play with the client vendors as well, right?
Nicholas, a question.
Yes.
We've seen the 2.5, 2.6, 2.56. Is there a way to do this type of stuff in 2.5 gig radios?
Is there? So the question, I think your mic is like, can we do this on 2 5 gig radios? Yes, kind of, maybe. It's all about isolation on the client device. If somebody wants to implement dual 5 and filtering on these, sure. Have we seen it yet? No. Have we seen clients that do 5 and 6 even in this form factor? Yes. Nothing preventing you from doing it, but I don't think you're going to actually see it in the real world. Simple question. I'm like, who do I pick on? Dev, how do you measure SNR?
How do you measure SNR? Signal to noise ratio, the signal strength.
Signal strength over noise. Like, it's simple. We all know this, right? So this is what I saw the other day when I was labbing with Wi-Fi 7. And yes, this is Meraki dashboard, you know, MLO. You have multiple links. And I was like, why is there an SNR value of 0?
Not being used.
Not being used. Now, I was like, this is surely a bug. Then I started looking at drivers, and then it dawned on me. How do you associate an MLO? Well, your association only happens on one radio link, right? And at least for me, this was a bit of an aha moment. The frames are only actually exchanged physically on one link, so you don't have signal on the other bands. That means everything when we're thinking about SNR, we have to start retraining our brains to think differently about SNR. What happens if you have a client with 2 links at the same time? Do you average? Do you aggregate? We don't have the answers yet, but keep in mind
both.
it could be both. Now, and yes, I am switching from a dashboard to controllers here because, you know, we're pretty dedicated.
Because you can.
Huh? Because I can. I looked at interface counters, right? There's nothing sent on the 5 gig, but I am associated. So we've also gone through there and said, okay, you're actually associated on these links, but we've never seen any traffic.
You had initially when you were showing a client, right, that's connecting on 5 and 6, for example. So it was active because when you were pushing traffic through it, right? So is there something that shows, like, I mean, SNR for both in that case in a scenario?
There is, and I'll show it. But actually, so what I'm trying to say here is we now have to start looking at TX and RX counters to understand if an SNR value is valid.
It's legitimate, yeah.
Something to think about. We don't have all the answers, but we're working through all of our assurance systems, our dashboards to make sure this shows up in a sane way. And all of you have to start thinking about how we're going to troubleshoot this and how we're going to implement this at client sites.
AI, bro.
To your question, yes, we do show up. Like if you have SNR on 2, and yes, Windows does show RSSI. Good thing is on the client, you're probably going to hear, you know, some probes or something going out so you can determine RSSI on the client side. But infrastructure side, you're only as good as your latest SNR measurement. But right now, you don't know when that is. Go ahead.
This is highly dynamic. Is there a way to have like an echo or some persistence? Because it might show up in the dashboard now.
Yep.
But not now. Now.
So we've built in persistence across the values. Like right now, Meraki dashboard, for example, shows the latest red value. We're working to enhance that on latest red value as of X time ago. I don't believe there is kind of a keep alive latest SNR, but that's something we need to look into.
I would just like to know, this is an MLO client, and it's actually using the multi-link 21% of the time.
Yep.
Or
and we're building those
history
kind
of
of
that.
statistics into our tooling. But everybody has built custom dashboards for tooling, whereas custom reports or, hey, dear Mr. Customer, what's your SNR out here? You have to start rethinking. It's like, well, what is the last SNR on this link? And oh, 2.4 might be different than 5. So SNR values, if you're averaging, are also potentially going to jump wildly. Anyways, a few moments just on security. We talked about this a little bit last time. But every band on an MLD must use the same AKM from a client's perspective. So if you're a client and you want to be in 2.4, 5, and 6, you need a common AKM across for a client level. Keep in mind, for SAE PSK, there's a new AKM 24 that you must support. Have fun. No. So that means, potentially, you need the same AKM on 2.4, 5, and 6.
Nicholas, what happens if initially you associate on a 5 gig channel and there's a DFS event? Do you have to reach all of the channels?
So it's a really good question. There's multiple answers. There are some parts of Wi-Fi 7 R2 where you can renegotiate links, you can pause them. We haven't fully explored that yet. But it is one of those things where it's not a roam anymore, right? Keep that in mind. It's not a roam, which is wonderful. but how can you pull links in and out of that? And there are some things in the R2 spec where you can start doing that, or we could theoretically deauth you on all, but that's not the greatest experience. Really good question. I like how you've started to think about this, because at least for me, it's like, oh damn, we have to rethink how we think about the most basic things such as RSSI and SNR. Coming back to security, real quick. If you're .1x, by far the fastest and easiest migration to Wi-Fi 7 because it's, you know, same AKM, you're happy. If you've got it working on 6 gig, your path to MLO is pretty painless. If you're on PSKs, well, this new AKM has to be introduced. Keep in mind, you don't want to orphan clients that don't know this AKM, so you're probably going to be running 8 and 24. And you're going to hope that your clients doesn't bug out if you have more than 2 AKMs. Hint, that is a really big problem for clients that don't certify. And then I was curious, what about OWE? What if I have a guest network? I did a bit of, I'm going to say my own stunts here. This is not Cisco's testing team. This is just me at home. A few different clients. Yeah, most of it is red. Some of the clients don't know how to connect even just Wi-Fi 7 transition mode. Some do single link. Some do MLO across. We're, again, in the early days of Wi-Fi 7 and enterprise, and this is the stuff we're working with the client vendors to kind of fix before it really makes sense to release Wi-Fi 7 products. Cool.
I have a question on MLO, and I mean, there's different modes. So is it something that you can configure on the controller, on the Meraki dashboard? Like I'm only going to support this MLO mode, or is it just
All or nothing.
Yeah. So one of the things you can do in the most rudimentary control is you can just say this band is not Wi-Fi 7 enabled. Like, sure, what do you lose? Okay, maybe 4K QAM. But let's be honest, that's probably not a big loss. Turn off 11 BE on the radio, you can pull that band out of an MLD. So that's the most rough control, but you can absolutely do that. And I do think we're going to see deployments where that's the case, right? Or you can tweak SSIDs to not be announced on those bands where you kind of want to pull them out. Now, on your question on can I refuse an eMLSR client to join or not, we haven't looked into kind of the rejection states yet.
okay?
But I will say on the controller and dashboard in our backend, we do get information about the client if it is eMLSR capable.
Filter.
We also do get capabilities around is it MLMR capable. Cool.
Are you going to expose that information in the GUI?
So
Be able to see client information like that?
it's a really good question, Kevin. I think I'll say we're going to probably follow our general guidelines where 9800, we're going to give you all the bells and whistles, bits and bobs and knobs and timers. On the dashboard, we'll find a way to present that in a simplified manner to give you just the information you make like makes sense for you, right? Of course, PCAPs, et cetera, it's important to get it in. And we are working with our UX research team to figure out, okay, what's the best way to show this? What would you do with that information? Is it to get a feeling for how many clients are out there? Are you going to want to reject them? How are we going to play around with this? But it's a really good question, Kevin, and it's definitely something we're considering doing.
Nicholas, one more
Yes.
question. Sorry.
I'm getting the signals from behind. That Brett's saying.
I'll be brief.
Go ahead.
This is just all fascinating. I haven't had time to type, but same as you have like primary channels, secondary channels. Now, when you are talking MLO 2, 4, 5, 6, do you have like a primary band and secondary bands?
Typically, the one you associate on first. That's kind of your primary run, right? I haven't gone deep enough yet to get all of the answers on that. But when you saw that 0 SNR, that is the one you associate on, and it kind of says, these are my partner links. Because it's MLDs and MLO, it becomes more transparent. It's just one association, right? And the different links are in there. Just one last comment before I get shooed off. It is very likely that enterprise grade, tri-band, this should probably say tri-radio, I'm sorry, APs will require more than 30 watts peak. That's also why I found it so important to talk about PoE in the beginning. You're hopefully all buying switches with more than 30 watts these days. If not, start pivoting that way. You're going to need it. All of this complex processing, multiple links at the same time, that processing takes up power. That's all I'm going to say with it. Oh, actually, I forgot I put a slide in here. Spectral capture is a great idea. I saw some of our friends yesterday talking about that. That's why it's in the controller since last summer. Anyway.